Hey guys, my name's Amir, and today we're going to be looking at where does 9.8 meters per second squared actually come from? We use this number all the time, but most of us have no idea where it comes from. So I'm going to show you how that works. So in school and in physics, you would have come across the value of acceleration as 9.8 meters per second squared several times. But the funny thing is, most people actually have no idea where this 9.8 meters per second squared comes from. Today I'm going to show you where it comes from. So when do we use 9.8 meters per second? We use it when we're usually using the formula Fg, or maybe weight, is equal to mg. So 9.8 is our value for g. But what does this small g actually mean? I mean, we know the units are meters per second squared, so we know it's an acceleration. So we actually call it acceleration due to gravity. So this acceleration due to gravity only happens on Earth and is pretty close for on the surface of the Earth. If you start flying into space, the value of g changes. But where does it actually come from? So to figure out where it comes from, we actually need to look at the fundamental formula for gravitational attraction. And the fundamental formula for gravitational attraction is actually g m1 m2 on r squared. So the gravitational attraction happens between two objects, and this is the formula for it. We have g, which is a constant, 6.67 times 10 to the minus 11, the mass of the first object, the mass of the second object, and r squared. And now we actually equate this to mg, so the mass of, for example, if we're trying to find the weight force of us, then we would use our mass and multiply it by g. So we'd actually equate this to mg, where m is the mass of the object that we're measuring. So if m is the mass of the object that we're measuring, this is the first mass, mo of the object. What is the second mass going to be? This is the mass of the Earth. So in this formula we have, what is the gravitational attraction between the Earth and the object that we're measuring, divided by r squared, where r is a distance from the center of Earth to the object. So if these two equations are equal, you can see that this corresponds with this. So we can see that the small g corresponds to the big G multiplied by the mass of Earth divided by the distance from the center of the Earth. So we can actually plug in some numbers to prove this. So the g constant is actually equal to 6.67 times 10 to the minus 11. The mass of Earth is 5.97 times 10 to the 24. And the distance from the Earth's center to the surface is approximately 6,371 kilometers. So we're going to put times 10 to the 3 and square that. Now, if you type this in your calculator, you should get something along roughly 9.8 meters per second squared. So this is where 9.8 meters per second squared comes from. So if you look at this value, g, this is actually completely independent of the mass of the object. So that's why they say everything on Earth falls at the same rate. That's why when you drop a feather and a hammer at the same time and you ignore air resistance, they will actually hit the ground at the same time, because everything falls towards Earth at the same rate, irregardless of the mass of the object themselves. And they will fall at 9.8 meters per second squared. I hope you enjoyed that video. Remember to tag your friends that don't understand where the 9.8 meters per second squared comes from, and like and comment as well. Remember, if you have any questions, you're always welcome to ask us and we'll answer them for you.